Hey Geometry, welcome to the fourth section from probability. We are going to be doing conditional probability in this section. So conditional probability is probability that changes once we know some more information. So given events A and B, the probability of event B occurring knowing that event A has already occurred is called conditional probability. So the notation we use for this, and we've already kind of glimpsed this a little bit, but this would be the probability of B given A. So that is, that little line there is the given symbol. So conditional probability, we can actually use this formula. It is the probability of B given A is equal to the probability of A and B divided by the probability of A. So given that A has happened out of the A, it's the probability that B also happens. So a number from 1 to 20 is, and that can be useful sometimes, so you don't always need to do that. A number from 1 to 20 is chosen at random. Find each probability. And so we're going to find the probability that it's prime given that it's greater than 8. And so ultimately we can do this a couple of ways. We could just think about, when we have the conditional, we can think about that as like a reduced sample space. So we could just think about the numbers greater than 8 and then figure out which ones are prime. But that's basically doing exactly what this is. So you can use this formula as well. So we could find the probability that it's prime and greater than 8. So that would be numbers like, I'm going to make a little note here. So like 11 is prime and greater than 8, 13, and 17 and 19. So the probability of getting a number that's prime and greater than 8 is 4 out of, and then numbers 1 to 20, 20. So we have 4 out of the overall 20, which is then divided by the probability that it's greater than 8, which would include the numbers 9 through 20, which ends up being 12 numbers. So 9, 10, so on and so forth, and then 11 through 20. So it ends up being 12 out of 20. So you could write it this way. This formula will work. You also could have just realized that there were 4 prime numbers out of the 12 that were greater than 8, because this does just simplify to 4/12, which simplifies even further to 1/3. And then you could write that as a decimal or a percent as well. How about a multiple of 3 given that it's odd? So we can kind of follow the same pattern, multiple of 3 and odd. So those would be like, make a little note, just a little list here. 3, so not 6, 9, not 12, 15, and not 18, and I guess that's it. So just those 3 out of 20. But then the probability that it's odd is 10 out of 20, and so then that just becomes 3/10. And so you could think about, given that it's odd, out of those 10 odd, we could do 3 out of 10. And that could be decimal or percent as well. At most 15, given that it's a perfect square. So up to 15 that are perfect squares. So I'm going to list those out. So these could be tricky to remember all this. So 4 is a perfect square. And I guess I'm missing, so 4, 9, and then so 16 would be next, but I guess 1 would be in there as well. So yeah, so that's 3 out of 20 that meet the conditions, and then the perfect squares all together. So then kind of continuing on, so we've got 16, and that's it. So it's just the 4 out of 20, and so that ends up being 3/4. All right, and then decimal or fraction. Probably it's 7 given that it's no more than 12. So the probability of getting a 7 that is no more than 12, that's just 1 out of 20. And then the no more than 12 is up to 12, so that's 12 out of 20. And so you just get that 1/12 probability. All right, a couple more examples with a different situation. A bag contains 8 red marbles, 2 blue marbles, 4 yellow, and 6 white. If a marble is chosen at random, find each probability. Find the probability that it's red, given that it's not blue. So we can do, probability of red and not blue. So red and not blue is just the red marbles. So 8 out of, and then how many marbles do we have in this bag? So that's 10, 20, 8 out of 20. And then, so that's red and not blue, because all the reds would also not be blue. And then given the probability not blue, and so there are 2 blue in there, so that's 18 that are not blue out of 20. And so this can be just 8 out of the 18 not blue ones, which we can reduce to 4/9. Yellow, given that it's not white. So again, I can follow this formula if we want. We can also write it out, just think about the non-white ones, but I'll stick with the same pattern. So yellow and not white are just the yellow ones, which would be 4 out of the 20. And then the not white ones, so there are 6, so that would be 16 not white ones. So really it's 4 out of 16, which we can reduce to 1/4. The spinner to the left is spun. Find each probability. So assuming this is a fair spinner, find the probability that it's shaded given that it's a vowel. All right, so our shaded vowels, so something that's both, A and B. So shaded vowels, I've got A, O, so these are kind of hard to read, in E. So we have 3 out of, and then we need to know how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 3 out of 16. And then, so we have 3 shaded vowels. And then we need to overall find the probability of a vowel. So we have A, E, O, I. Is that it? So that's out of 4 out of 16. Which gives us, that rule simplified to 3/4. All right, 3 out of the 4 vowels are shaded. And the next one, probably there's a consonant, given that it's unshaded. So get back over here and do this work. So consonants that are unshaded, so those would be B, C, F, K, and N, and P. So 1, 2, 3, 4, 5 meet both conditions. So 5 out of the 16, same 16. And then how many total unshaded are there? I think I counted that wrong. 1, 2, 3, 4, 5, 6. Yes, I did. Yeah, so it's 6 out of 16, and then this is 7 out of 16, which of course reduces to 6/7. 6 out of the 7 unshaded ones are consonants. And then last one here on this page, a card is chosen at random from a standard deck of cards. Find the probability that the card is an ace, given that it is a diamond. So ace and diamond, there's only one of those, so that's a 1 out of 52 chance. And then the probability that you get a diamond, that's one of the suits, so you could just write 1/4. You can also, there are 13 diamonds, so if it makes it a little easier, you could do this either way and you'll get to the same result. 13 out of 52, so that's a quarter of those 52 cards are diamonds, and so probably that you get an ace, given that it's a diamond, is 1 out of 13. So that is the start of that. We'll continue in a second.